So hello everyone, welcome to Concepts in Chemistry YouTube channel. So today we will discuss memory based questions and their maximum possible answer uh, from Barc 2022 first phase exam. So maximum possible answer, yeah, we are saying that this maximum possible answer means, yeah, for some cases the answer may not be correct, but yeah, we will try to give 98% to 99% correct answer. So let's start. So this video is part on, so we will upload more videos because it will take time. You all know that to remember questions, all questions, uh, so to remember all questions, usually it will take some time. So we will discuss around 14 to 15 questions in this video. So in our upcoming video we will upload more videos. So let's start. So first questions from physical chemistry. So from Michaelis-Menten kinetics. So this is a simple questions. So we all know the Michaelis-Menten kinetics mechanism. So from there, every time in GATE or NET, usually on questions in every year, normally they used to ask in every year, either NET or GATE. So in Barc also. So this time a simple questions from Michaelis-Menten kinetics asked. So in the questions, slope is given as 0.16. So I'm not mention that unit. So slope is given as 0.16 and intercept is 2.12. So from this value, and mention that from the plot of on by reactant concentration and on by on by rate. Plot of on by rate means reciprocal of rate, and plot of on upon substrate concentration. So from this graph, the slope is 0.16 and intercept was given as 2.12. So from this value we have to find the Km, means Michaelis-Menten constant. So this is the normal normal equations of Michaelis-Menten constant. R is rate, R max is maximum rate, S substrate concentration, Km Michaelis-Menten constant. So R max, S, Km plus S. If we rearrange these equations, then we will get 1 by R. R is rate, R max is maximum rate. So we will get these equations. If we plot 1 by R versus 1 by S, then we will get mx plus c. M is slope, Km by R max. Slope Km by R max, intercept 1 by R max. So slope is given as 0.16 and intercept 2.12. So so Km, see here, slope equal to Km by R max. So we can write slope equal to Km into 1 upon R max is intercept, y intercept. So we can write Km into intercept equal to slope. Now Km equal to slope by intercept. So slope was given as 0.16 and intercept 2.12. So the answer is 0.075. So there is 4 options out of 1 is 0.075. So this is the correct answer, 0.075. This is the simplest question from chemical kinetics. So from this equation, slope equal to, we can write Km. We just put 1 upon R max. 1 upon R max means intercept. In this equation, Km into 1 upon R max, we put the intercept value. Km into intercept. Intercept means 1 upon R max. So Km by R max, we can write Km into intercept. This 1 upon R max is intercept. So this is equal to slope. So Km is equal to 0.075. So this is the simplest questions from chemical kinetics. Now second questions. So from electrochemistry to simple, very easy questions they are asked. So I think 3 to 4 questions from electrochemistry they asked this time, but uh, till now two questions we will discuss in our upcoming video. We will discuss more videos. So in a redox reactions, so in a redox reactions, ratio of oxidized species to ratio of reduced species is given as OXD upon rate, means OXD means oxidized and rate means reduced species, equal to E square. So now there are 4 options. Which option is correct for this statement? These are statement in a redox reactions, ratio of oxidized species to ratio of reduced species is like this. Which of the equations or equation is correct for this statement? So for normally we know oxidized species plus Ne equal to reduced species. So we all know that Zn2 plus cadmium 2 plus 2 electron cadmium. So oxidized species upon accepting electron transform into reduced species. For these equations we can write the cell equation E cell equal to E0 cell minus RT by NF ln reduced by oxidized. This is the cell equation for this type of redox reactions. Now we can write E cell, this E0 cell if we write this E0 cell into the left side of the equal sign, then E cell minus E0 cell equal to, we can write minus RT by NF ln rate by oxt. Now in the questions it is given like oxt by rate. So if we change the sign, if we change the sign RT by NF, then we can write this oxt. Just we have to do the opposite means oxt will go to up and rate will go to the below. So if we change the sign, this term in ln just shift the place of is this rate term will go to below and this ox term will go to up if we change the sign. We all know the properties of ln. Now RT by NF ln ox by rate. So in this statement ox by rate was given as E square. If we put the value of E square here, then we will get RT by NF ln square. Now ln and E will cancel out, 2 comes to here before ln. So this E cell minus E0 cell equal to 2 RT by NF. So 4 options like this 4 options like this was given in the questions. So from these questions the correct answer is E cell minus E0 cell. Yeah, might be there is a mistake to write the options, but the correct answer is this E cell minus E0 cell 2 RT by NF. So 2 RT by NF, there is minus options, plus options. I think one option is RT by NF, because in this case in the case 2 is there, E square. So this is a important things to notice. That's why, yeah, obviously there is RT by NF term. So the correct answer is not minus, plus 2 RT by NF. So this is the correct answer. So move to the next questions. So this is also from electrochemistry. So the E0 cell of this Zn2 plus Zn was given as 0.7. Yeah, I am telling you that I am not mention the whole value here. In many questions I am not mention the options also, or the full form of any equations, but Zn2 plus Zn E0 cells is like 0.74 something. So yeah, sign is positive but 0.743 something. So I forgot the value, but 0.7 something. So E0 cell cadmium 2 plus, this half cell this E0 cell of this half cell is 0.7 something volt, E0 cell of cadmium 2 plus, this half cell is 0.4 something volt. There is something after this point 0.43 something. So this is the E0 value of the half cells. Now this is the cell equations. This is the cell. This is the cell. Yeah, from this cell we have to find in this case also 4 equations are given, but we have to find the correct equations, cell equations. So see, we all know this is cell, and the right side of the cell known as we all know right side of the cell is known as right hand electrode or cathode, where reduction will happen. In left hand electrode normally we called as a anode, where oxidation will happen. See here, you can see here cadmium 2 plus transform into cadmium. This is mean reduction. Zn to Zn transform into Zn2 plus. This is oxidation. So right hand electrode reduction occur. Normally left hand electrode oxidation occurs. So right hand electrode cathode, left hand electrode anode. So this is the right hand electrode where these reactions will happen. Cadmium 2 plus accepting 2 electron become cadmium. Left hand electrode reaction, this reaction will happen. Zn2 plus release 2 electron. So left hand side oxidation occur, right hand side reduction occurs. But E0 cell of this E0 cells means standard cell potential is ER minus E left. ER means electrode potentials of right hand cell. Obviously these are reduction potential. These are reduction potential of right hand cell minus reduction potential of left hand cell. So in the question given cadmium 2 plus, that is right hand electrode. So this is reduction potential of right hand cell. This is reduction potential of left hand cell. So ER minus E left. So 0.3 is 0.3 or 4. Yeah, it's maybe 0.3 or 0.4. So if it's 0.4, then it is also okay. But the E0 cell become negative. It's not positive. In this case, ER means right hand electrode is the cadmium 2 plus electrode where reduction occur. Left hand electrode is Zn 2 plus Zn electrode where oxidation occur. So E0 cell is ER minus E left means this cadmium cell minus this zinc half cell. So it's become minus 0.4. If it is 0.4, then it will become minus 0.3. Now this is the whole cell reactions. Whole cell reaction means if we add these two half cell reactions, then we will get the whole cell reactions. Cadmium 2 plus become cadmium 2 plus become cadmium, Zn become Zn2 plus. So this is the whole cell reactions. For these cell reactions, if we want to write the cell equations, then E cell is the cell electrode cell potential, E0 cell standard cell potential minus RT by 2F. In these reactions, in this half cell reaction C, 2 electrons are involved. So RT by 2F we put in place of N 2 here. In the previous case C, N is there. So in this case N is equal to 2F ln minus RT by 2F ln Zn2 plus this cadmium and these zincs, these are solid. So this we can assume the activity of the solid as unity. So Zn2 plus upon cadmium 2 plus. Now see in the cell the concentration of cadmium 2 plus is given as 0.1 molar and the Zn2 plus is 0.01 molar. So in these equations Zn2 plus cadmium 2 plus. So E0 cell become minus 0.03 minus RT by 2F ln Zn2 plus concentration 0.01 upon 0.1. So if we change the sign, means minus 0.03, if we change the sign plus, then the term within the ln will Zn2 plus become below and cadmium 2 plus go to up. So minus 0.03 plus RT by 2F, we just change the sign RT by 2F, then cadmium 2 plus will go to up and Zn 2 plus will go to below. So now the whole equation become ln 0.1 upon 0.001. So in on options minus 0.3 plus RT by 2F ln 0.1 upon 0.001 was given. So that was the correct answer. So you have to write the cell equation first and carefully the concentration term, which concentration will go to above and which concentration term will go to below. And if you can write this cell equation properly, then this change in sign does not matter. If you have minus ln Zn2 plus by cadmium 2 plus, if you write plus signs, then ln Zn2 plus cadmium 2 plus become ln cadmium 2 plus by Zn2 plus. Just this term will change their position. Zn2 plus will go below, cadmium 2 plus will go up. This is the function of ln. So 2 questions from electrochemistry are asked, and that those are very easy questions, so straightforward questions. So next move to the question number 4. So this 4 cyclobutane, cyclobutane was are given. So among them, which one is optically active? So this is trans on 3 dichlorocyclobutane. So these are optically inactive because plane is there. This is above the plane, this is below the plane. So in this way, one plane is there. So that's why it's optically inactive. This is also cis on 3 dichlorocyclobutane. This is also optically inactive because there is 2 middle plane, one from this side and one from this side. In this case, only one middle plane bisecting this chlorine CCl bond, this CCl bond, on middle plane. So this is also optically inactive because here middle plane in this bond bisecting this middle of this 2 CC bond, middle plane is there. So this is also optically inactive. 1,2 trans dichlorocyclobutane is optically active. So only this is optically inactive. So this cyclobutane dichloro trans 1,2 dichlorocyclobutane is optically active. Now one question from point group is cis mx2l4. So this is the complex mx2l4. Point group of this compound is, we all know that this type of complex point group is C2V. So XX cis and L4. So cis this type of so we all know that this type of cis complex, cis octahedral complex X2L4, point group is C2V. If it is trans, means mx2l4 trans, then the point group will be D4H. Means if 2x are in trans positions and 4l are in the plane, then the point group of that complex will be D4H. In the question, cis complex was given, so the point group is C2V. So 4 species are given. Next questions, that is nitrate, carbonate, sulfur trioxide and sulfite. So among them, isoelectronic and as well as isostructural, we have to find which pair are isoelectronic as well as isostructural. So if we count the electron of NO3 minus, so nitrogen 7 electron, 3 oxygen 24 electron, 1 negative charge 1 electron 32. For carbonate, carbon 6 electron, 3 oxygen 24 electron plus 2 negative charge 2 electron 32. So for nitrate and carbonate, electron count is same. So we also know the structure of nitrate and carbonate are trigonal planar. So nitrate and carbonate have similar structure and isoelectronic, means they have same electron. So this is also a simple questions and easiest questions. This type of question normally asked at least one question, this type of questions regarding structure of species. normally asked in NET or GATE also. So let's move to the next question. From organic chemistry, this question was given. This is the reactant cell tube, 240 degrees centigrade. So we all know that 3,3 sigma-atomic rearrangement will happen in this reactions. So if 3,3 sigma-atomic rearrangement happen, then we will get this type of product. So this is an enol. It will transform to the keto form. So this is the product of the reaction. So there are so many options, but this is the correct option and this is the actual product. So in this case, 3,3 sigma-atomic rearrangement will occur. So this is CH2O CH3 radical was given. Question was how many hyperfine line we will observe from this in EPR. So in EPR, how many hyperfine line we will observe? So there are two types of hydrogen C. One type of hydrogen CH2, another type of hydrogen CH3. So you all know 2Ni plus 1, 2Ni plus 1. So 2NHA, this type of hydrogen, plus 1 into 2NHBI plus 1. If we count, so 2 hydrogen, 3 hydrogen, so 3 into 4, 12 line. So we will observe for this radical 12 hyperfine line in EPR spectra. So this is the questions. So on A star was given like that, and Grignard reagent. So this is a Grignard reagent, CH2 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 MgBr MgBr. So one equivalent is given. In one equivalent Grignard reagent, there are two. In one equivalent of this Grignard reagent, two equivalent of magnesium bromide is present there. So possible is there possibility. So there are two. So two equivalent of Grignard reagent. So one equivalent of this whole molecules contain two equivalent of magnesium bromide in each side. So double attack possible, and in here double attack will be occur. So this type of options will be there. So if we see the reactions, first this in will attack this A star. So O negative now return and leaves this OET group. So here OME, here OET is there, not OME group. Now second MgBr, first it will attack intermolecular, then this end attack this carbonyl with intramolecular fashion. So now this is the product. After aqueous NH4Cl workup, we will get this kind of alcohol. So 5-member ring and 6-member ring both are there, but the correct answer is 5-member ring. This alcohol, cyclic alcohol, the correct answer. More on option was there. So this kind of option is there. More options, another on option is there, but the correct option is this. First, this site attack intermolecularly this A star, this negative charge back and release this OAT. Again, this site of this Grignard reagent attack intramolecularly to form the alcohol after aqueous NH4Cl workup. So next move to the, so this is the questions. So this question was given. There are 3 OH group. So acid strength of 3 different H. So HA, HB and HC. 3 H marked as HA, HB and HC. These are alcoholic OH. So you have to find the strength of this acid strength of this H. So this there is a confusion still. So I am frankly speaking that I have confusion. So from these questions we can see that if this H is abstracted and if we consider the conjugate base of conjugate base, corresponding conjugate base, then the negative charge on this O minus will resonate with this double bond and shifted to the this CO oxygen. So if we abstract this hydrogen C, the corresponding anion or conjugate base will be more stable. Conjugation, there is extended conjugation, conjugate with this double bond and then conjugate with this carbonyl compound. So HC is more acidic, but there are two options. So C A B and CBA. So still I have confusions. So this is a normal 2 degree alcohol, this is a vinylic alcohol. So this from this alcohol one carbonyl group is there, adjacent to this alcoholic OH on carbonyl group is there. This is simple 2 degree alcohol, this is vinylic alcohol. So from this 2 OH, so I believe the hydrogen of the acid, the acidity of this OH is more than this vinylic OH. But yeah, frankly speaking, I am not sure about these questions, but yeah, I remember this question and I put into the video to show you. But yeah, I will try to find the exact reason and exact answer for these questions. Yeah, I will find, and I am telling you guys, I will try to find the exact reason with some reference. So that's why this is some I have confusion still. So more than 50% I believe that C is more, the acid strength of CH is more than HA and then HB. So you guys also think what will be the result, what will be the answer. So and comment in comment box. You can also analyze these questions, and you can also share your answer in comment box. So this is on questions, and one questions from basicity. So this saturated heterocyclic nitrogen heterocycle, so piperidine, pyrrolidine and azitidine. So basicity order of these three heterocyclic saturated heterocyclic compounds. So we all know that basicity means the lone pair availability. We can consider the lone pair availability of the lone pair on each nitrogen atom. If the lone pair is more available, then it will more basic. So this is the one way. Another way, if we consider the corresponding conjugate acid by protonating this lone pair, of each molecule, then we have to consider the stability of the conjugate acid or acid strength of the conjugate acid. But the easiest way or simplest way is to consider the lone pair availability of the on the nitrogen atom. So we all know the piperidine C, this CNC, or normally the internal bond angle in the ring is around 120 degree. We all know. In pyrrolidine 5-member ring, the CC bond and this CNC bond around 108 degree, and this 4-member ring, the CCN bond, this internal bond is around 90 degree, since this is a cyclobutane ring. So we all know from the with decreasing bond, with decreasing the bond angle, means we know sp hybridized carbon bond angle 180 degree. So percentage of S character 50%. sp2 bond angle is 120 degree, percentage is 33.33. sp3 bond angle is 109 degree, percentage of S character is 25%. So with decreasing the S character of particular orbital, decreasing the S character of a particular bond from sp to sp2 to sp3, the percentage of S character will also decreases. So more the bond angle, there will be more percentage of S character. sp bond angle 80 degree, percentage S character 50%. sp2 bond angle 120 degree, percentage S character 33%. sp3 bond angle 109 degree, percentage S character 25%. So with increasing bond angle, percentage of S character increases. So see, this internal bond angle, this CNC, or you can consider CCN, this internal bond angle is 90 degree, in this case 108 degree, in this case around 60 degree. So from A to B to C, the internal bond angle CNC. So the internal bond angle A 90 degree, B around 108, C around 120 degree. So if we move from A to B to C, the internal bond angle of this heterocycle increases. Now with increasing bond angle, the percentage of S character, so from A to B, the internal bond angle means this CNC bond angle increases, means the orbital directed towards this bond, the orbital of nitrogen directed towards this bond, the orbital of nitrogen directed towards this bond, and the orbital of nitrogen directed towards this bond. Obviously this is a hybridized orbital, sp3 hybridized orbital normally. So the percentage of S character of the orbital of nitrogen directed towards this bond is somewhat greater than this, because this bond angle is 90 degree. The percentage of S character of the orbital of nitrogen directed toward this bond and this bond is the percentage of S character of orbital of nitrogen directed toward this bond is less, because this bond angle is 90 degree. In this case the bond angle is 108 degree. So the percentage of S character of nitrogen, percentage of S character of the orbital of nitrogen directed toward this bond is somewhat greater than in case of aziridine. If we compare piperidine, so since this CNC bond angle is 120 degree, we can say the percentage of S character of hybrid orbital of nitrogen directed towards this bond and these bonds is somewhat greater than pyrrolidine. So in the 3 saturated heterocycle, the internal bond angle is more in case of piperidine. That's why the percentage of S character of hybrid orbital directed toward this C bond, hybrid orbital of nitrogen directed toward this C bond is have more S character. That's why the percentage of S character of the orbital containing the lone pair or the orbital containing the hydrogen atom has somewhat less S character. Since in case of piperidine, there is maximum S character of the orbital of nitrogen directed to a CC bond, internal CC bond. That's why the percentage of S character that containing the lone pair or this hydrogen is of lowest. Maximum S character containing orbital is directed towards this CC bond. But in case of pyrrolidine, the bond angle is less than pi per radian. That's why the percentage of S character of nitrogen atom, if it is say if it is around so it's around 20, not 25, it's around 30%. The orbital directed towards this CC and this C bond is 30%. That's why the lone pair containing the orbital S character become less than 25%, means around 20% or less than 20%. In this case, the percentage of orbital of this nitrogen directed towards this CC bond somewhat lesser than this case. That's why the percentage of S character of orbital containing this lone pair is somewhat greater than this case, and in this case the percentage of S character containing the lone pair is most S character. The lone pair containing the orbital containing lone pair is lone pair. In this case, the percentage of S character of that orbital is most. So we can say that in this case, pi per radian, the lone pair rests in a hybrid orbital which has less S character. So less S character mean it is more available for attack. So that's why in among these three nitrogen bases, piperidine is more basics. So piperidine's lone pair is more available. Piperidine lone pair is lone pair containing orbital has less S character. So pyrolidine lone pair containing orbital is moderate S character. Azacitidine lone pair containing orbital is more S character. So less S character orbital means this lone pair is more available. So on the basis of lone pair availability, we can say that the piperidine is more basic. So basicity of this basicity order is C, then B, then A. So internal bond angle more, S character of orbital directed towards this bond is more. So the outside orbital S character is less. This is the main theory. Internal bond angle more, S character more, outside orbital S character become less. So since this lone pair containing orbital has less S character, it is more available for attack. That's why basicity order of these three bases is C greater than B greater than A. Now rate of hydrolysis. These three compounds are given. So rate of hydrolysis. So in both of them, you can see oxygen group is there. Here oxygen, here double bond. So in both of them, in three of them, neighboring group participations can possible. This this oxygen lone pair can attack these positions. This will leave. So then again nucleophile means water will attack this position. So now from A and B if we consider, so this is a flexible structure, 8-member ring. So this oxygen lone pair, this is a flexible, large ring, flexible. So oxygen easily donate the lone pair and attack these positions to release the Cl minus. So and that is less favorable for 6-member ring. You can see the transition state after attacking this oxygen lone pair, there will be 2 5-member ring. This oxygen attack this position, 1, 2, 3, 4, 2 5-member ring will form. In this case, after attacking this, if we see the transition state, then we will see 2 4-member ring is formed. So this is more stable than this. So that's why neighboring group participation is more favorable in this case, B, if we compare A and B. But in this case, double bond is there. So still one confusion, like the question 10, still one confusion is there. So from A and B, B is more favorable toward neighboring group participation. So rate of hydrolysis is more in B, but there is double bond. So if you compare B and C, so this is a heteroatom, this is a double bond. So both can participate in neighboring group participations, but still there is some confusion. So if there is sulfur kind of atom, then normally neighboring group participation will occur easily. But oxygen is electronegative atom, and here is the double bond. So I think double bond will participate faster in neighboring group participation than this oxygen atom. If there is sulfur atom, then this sulfur is less electronegative, and sulfur atom is sulfur is more nucleophilic, so it will attack this position easily. So in that case, we can say that this will hydrolysis of this compound will occur faster than this. But still we have confusion. So this is the question. So in my opinion, first the rate of hydrolysis will be first C, then B, then A. So you can also try to analyze, try to find reactions. So question 10 and question 12 we will discuss later by finding proper reasons and proper answer with reference. So till now just see the questions and you can also try to find the answer. So rate of hydrolysis. So the main theory is here neighboring group participation will occur. In this case, double bond will participate in neighboring group participations. In this case, heteroatom lone pair will participate. So among these two, B will rate of B is very high. It's confirmed, but among B and C, I cannot sure. So try to analyze these reactions and share your answer in comment box. So let's move to the next questions. So yeah, this question. So I don't think that in previous any exam like NET, GATE or Barc exam, this type of question normally asked, but I don't remember. So yeah, I think a few days ago, 2 or 3 days ago, in our chemistry concept booster series, that is chemistry concept booster question number 6, we will discuss these questions details. So really I am telling you guys that I don't think, I also I don't think this type of questions will be asked in any exam, but luckily exact same questions is asked, exam same questions they asked in this exam, Barc 2022 first phase chemistry. So how can we increase the efficiency of Carnot engine? So by lowering the temperature of HTR, means high temperature reservoir, or you can say source. By lowering the temperature of low temperature reservoir means sink. High temperature reservoir means source, low temperature reservoir means sink. So this is the formula of efficiency, T minus T dash by T. T is the temperature of high temperature reservoir, T dash is the temperature of low temperature reservoir. So 1 minus T dash upon T. This is the efficiency of Carnot engine. So there is two options. We can increase the efficiency value. If we decrease this term, if we decrease this term means T dash term, if we decrease the temperature of LTR, then this whole value become decrease. Also, if we increase the T term means temperature of high temperature reservoir, then also neta will increase. Question is, among these two options, which is the effective way, which is the effective way we can increase the temperature or the efficiency of Carnot engine. So the question is not, the question is the correct answer or the exact answer is, if we decrease the temperature of low temperature reservoir, then the efficiency of Carnot engine will be higher. Not if we increase the temperature of T. There is two options. If we increase the temperature of T, then this term will become high. If we decrease the T dash term, means temperature of low temperature reservoir, then also this term become high. So among these two options, which is the correct way to increase the efficiency of Carnot engine. So yeah, I am very happy that I already shared the video. I think first time this type of question generally not asked in not asked in competitive exam, but yeah, around 2-3 days ago I uploaded this chemistry concept booster series question number 6. So and I discussed details about the questions. So I am very happy that directly the questions is uh, they set the questions directly. So from if you guys will see the video, then you will understand that yeah, I also mentioned there that normally this type of question normally uh, normally don't uh, this type of question normally so in that video I mentioned there this type of question, this type of questions normally set this type of question normally. So previously any competitive exam you cannot find this type of questions, but luckily in this Barc exam they asked, and I feel very happy that I already discussed particularly these questions in a separate video, that is chemistry concept booster series question number 6. So yeah, if you can see the video, if you will see the video, then you will understand the details concept about this. So the perfect the correct way is to decrease the temperature of low temperature reservoir, means STR, to increase the efficiency of Carnot engine, not to increase the temperature of HTR, means high temperature reservoir. So the correct option is by lowering the temperature of low temperature reservoir. So let's move to the next question, and I think this is the last question. So for part on, so the rate and rate constant have same unit. So the question was like that, for which order of the reactions the rate and rate constants have same unit. So we all know the rate, we can write dr dt equal to kn r to the power n for nth order reactions. I don't mention here the sign. We have to focus on the rate unit only. So that's why. So from these equations, kn equal to, we can write rate by r to the power n. Now rate equal to dr dt r to the power n. So kn equal to, so rate we can write rate, unit of rate key. What is the rate of unit? Mole per liter. So unit mole per liter per second. So if we consider the only the term r, this is d term, means difference. R means reactant concentration, mole per liter. T second, so mole per liter per second, and in the denominator concentration power to the power n for n other reactions. If we rearrange this, then we will get mole 1 minus n, liter minus n plus 1, this n mole power n, if mole to the power n goes out above, then become minus n. If liter n minus n, if we go up, then become plus, so minus n plus n second inverse. So for any nth order reactions, the unit of rate constant is like that. If we put n is equal to 0, then you will get mole n is equal to 0 per liter per second inverse. For 0 order reaction, unit of rate constant. For for the first order reactions, this becomes 0, this also becomes 0, only second inverse. We all know that for first order reactions the rate constant unit is second inverse. So if you put n is equal to 2, then you will get the corresponding unit of rate constants. Now see here, rate we can write dr dt. So r by t, these different term. R means reactant concentration, T time. So mole per liter second. So unit of rate is mole per liter per second. So unit of rate is mole per liter. This is reactant concentration mole per liter upon T means second. So mole per liter per second is the unit of rate. And from this equations we can easily find the unit of zero order reaction. If we put here 0, then we will find mole per liter per second. So for zero order reactions, Kn, unit of Kn means unit of rate constant is mole per liter per second. So for zero order reactions, the unit of rate and rate constants are same. So for part on memory based questions, we discussed 14 questions. Out of them 2 organic questions we have doubt. So we will discuss upcoming videos. In the meantime, we will try to find the exact answer and try to find some reference. So these are it's, I believe the all the questions are very straightforward and not so much tough. So it's the questions are in the easiest side. So the I feel like so among 14 questions, so 12 questions I believe that the 99% or more than 99%, 99.99% answer will be correct. So I frankly told you that the 2 questions from organic chemistry I have still confusions, so we will discuss later. So thank you for watching. So we will upload more videos for memory based question answers. So stay tuned. Thank you for watching. Stay safe, stay healthy.